Okay, guys. So today, yeah, the sole focus is on graphs, isn't it? And Q functions to be exact. Now, right. So we're going to take a look at those, right? So the first one here gives us the equation, which is negative x cubed plus 6x squared minus 9x plus 4, and then they give us the factorized version of it, right? Usually, good people, when you see an equation like this, ne, when you see a squared here, right, it means that this type of graph, ne, one of the, this means one of the x-intercepts, ne, one of the x-intercepts is also a turning point, okay? Is also a turning point. All the time you should check for those type of graphs. It means that graph might be looking like this. Maybe it's decreasing and then increasing, and then the graph might be looking like this, or maybe the graph might be looking like this, or whichever way there, right? Maybe it might be, like this and then like that, right? The point is that one of the x-intercepts is also a turning point, to understand me. So whenever you see this squared there on the factorized version, that's what it means there, right? So it says determine the coordinates of the turning points of f, right? The moment we talk about turning point, I need you to know from now that we shall focus on the moment he says turning points, then you should know that, oh, okay, it means we're talking about the derivative. Like, you must find the derivative. And get, so the first thing you're going to do on 8.1 is to find the derivative. Once they talk about turning points, so you shall say, okay, the derivative of f will be negative 1 times 3 there. Remember, it will be negative 3, and then x, and then remember you say 3 minus 1, that would be 2 there, right? Then here 6 times 2, that is 12, right? And then you have 2 minus 1 is just 1. And then here you have negative 9x. Remember, you simply take the negative 9 and get, and then you have found the derivative there. Remember, the derivative of a number is 0, right? So that one, just leave it out. Then remember, at the turning point, right? At the turning point, the derivative would be equal to 0. So therefore, you are going to say 0 is equal to negative 3x squared plus 12x minus 9, which means you will have 3x squared minus 12x plus 9 is equal to 0. I think here, because it's 3, 3, 3, from here you can use the quadratic formula, good people, right? However, knowing myself, I'm going to attempt, factorizing it. We have x squared minus 4x, right? And then plus 3 is equal to 0. Now we can factorize this and say x, 3 and 1, negative, is equal to 0. So therefore it tells you that your x will be 1 or your x will be 3. These are the x coordinates of the turning points. You understand me? These are the x coordinates of the turning point. Now remember, you need the coordinates of the turning point, the full coordinates. So you shall need to get the corresponding y values, right? So how do you get the corresponding y values? That is when you are going to then say, just give me a second here so that you can maybe create some more space, right? Okay, so you shall then say, since x is 1 there, we'll substitute into the original equation, right? Usually I like to substitute in the factorized one because I'll get my y values much faster, but you can still just say, where you see x, you put 1 and stuff so that you get your y values, right? So that will be f of 1. Let's remember that f of 1 means the y value when x is 1, right? So we shall then say 1 minus 1 all squared into negative 1 plus 4. You see, where I see x, all I'm putting there is what? Is 1, because I want to find the corresponding y value there. Now, 1 minus 1 is simply 0, and then squared, this one is 3. So the answer will be 0. Therefore, the first turning point or stationary point is 1 and 0. Do you see it? Do you still remember the statement I said? I said one of the x-intercept is a turning point. And you can see this point is an x-intercept because y is 0 on the x-intercept. Okay, so that's what you must look out for. It's also a turning point. And then you say f of 3, right, means when you see x on the equation, you just be putting 3 there, right? So you will say 3 minus 1 all squared, and then negative 3 plus 4, right? Which will mean that you have 2 all squared. 3 minus 1 is 2. Negative 3 plus 4 is 1. Ne? So your answer will simply be 4. Therefore, the next turning point is what? Is 3 and 4. Okay, that is the coordinates of the turning point. You get 8.1 there. Right. If there's any question, please do not hesitate to ask. 8.2. Now we need to sketch, right? Draw the sketch of f clearly showing everything there, right? You only got the turning points, good people. Remember, to sketch a cubic function, you're going to need the following. You're going to need the y-intercept. You're also going to need the x-intercept. And then lastly, you're going to need the turning point, isn't it? So already this one check we already have, right? So let's get the y-intercept, good people, right? To get the y-intercept, remember, our equation is f of x is equal to negative x cubed plus 6x squared minus 9x plus 4, of which in the factorized version it's x minus 1 all squared negative x plus 4. It's negative x plus 4, right? And now that you will have this, right, you can then try to find the y-intercept first. How do we get the y-intercept, good people? Let's remember that to get the y-intercept,
x equal to 0.
Perfect stuff. We let x equal to 0. So when we see x, good people, let's make sure that we will be putting 0. So we can say f of 0 is equal to, remember this whole thing is y. If you don't want to work with f of something, you can simply say you have y there. The only disadvantage with working, with that one, I think is that you need to get used to f of something, so that you can do the high order questions, right? Right. So it means you say y is equal to negative, you put 0, and then you put 0, and then you put 0 there, right? So in that case, your y will be equal to 4. So this means that when x is 0, the y value is what? The y value is 4. All right? So mind you, I was working with this version there. Then to get the x-intercept, right? To get the x-intercept, remember what do? We let y be 0, right? Which means where we see y, we'll put 0. Remember, this whole thing is y. So we shall put 0 there and say we have negative x cubed plus 6x squared minus 9x plus 4. Now, you could take everything to the left so that the x cubed becomes positive, and then here it becomes negative, positive, and negative, right? Now you are faced with this situation and you must factorize first. You must factorize. Okay, what would you do, right? Now that you are here, what would you do? Well, good people, remember, do not waste your time trying to use the synthetic division method so that you can factorize this. Why is that? In fact, let me rewrite it like this. Yeah. Yes, ma'am?
Sorry, sir, can you please repeat your question?
Right. So we have the following, right? Essentially, since it's a cubic expression or a cubic equation there, you will need to factorize. For example, let me just say you had x squared minus 4x plus 3. Ne? When you're solving for x, remember what do you do here? You factorize, right? You factorize in there x minus 1, x minus 3, or use the quadratic formula. Again, so that you could get the x-intercept. You say, therefore, my x-intercept is 1, or I'm just making an example here. However, right? However, for our question here, right? For us to solve for the x-intercept, we actually need to factorize this. But
What if we use the factor and the factor theorem?
Factor and remainder theorem, right? You could do that. You understand me? You could do that. However, you would be, working the hard way. You would be working the hard way. You would do that if only they had not already factorized for you. Do you see that they already factorized for you? Are you able? Yes, because they already factorized for us. There is no need to use either the synthetic division method or the factor remainder theorem. What we can simply say is just to say x minus 1 all squared negative x plus 4. They already factorized for us. Now it makes it a very, very easy question, because now we can now simply say the first bracket. Remember that this first bracket, you can rewrite it as x minus 1 times x minus 1, right? And then negative x plus 4. Now remember, you can therefore say x minus 1 is equal to 0, or x minus 1 is equal to 0, or negative x plus 4 is equal to 0. So which means your x will be 1, or your x will be 1, or you can take that to the other side, your x will be 4. So what are these x values that we are getting? Good people, these are your x-intercepts, right? See if I can get a different color here. These are your what, good people? These are your x-intercepts. This one was your y-intercept. These are the x-intercept. This is the equation we are using is this one, right? This is our equation here. Right, which is the equation that was given in the question, this one. Now, from there, right, we can therefore say, our x-intercepts will be 1 and 0. This is also 1 and 0, so we can just say 1 and 0 and 4 and 0. Okay, these are your x-intercepts. Remember, for x-intercepts, y is 0. Then now that you have this, you can now say, okay, I now have this and that. I can now sketch. Now to sketch that function, good people, right? It's quite easy. Remember to draw your Cartesian plane. Remember, I like to start with the Cartesian plane first, right? So draw the Cartesian plane like this. And then from there, this will be x, this will be y. Now remember what I said. Number one, do we start with the Cartesian plane? Remember, I don't start with the Cartesian plane. Why am I doing what I don't do first? Evan. Sorry, man. I don't start with the Cartesian plane. I start with this. Joe. Sorry for that. So I start with the shape of the graph first, right? Now, how do I get to know the shape of the graph, right? Check here, good people, on the original equation of the graph. Negative x squared plus 6x squared plus that. Let me actually rewrite it here, right? We have negative x cubed, why am I saying squared? And then you have 6x squared, you have minus 9x, you have plus 4. This is your equation, right? To sketch that graph, you simply look at the value of a, right? Your a is negative, right? Which means the shape of the graph is decreasing, increasing, and then decreasing. Okay, let's try to draw it nicely. Right. So this is how the graph is. However, you're not done. Obviously, you need to put in your as you know, staying indoors is something else. Okay, sorry for that, good people. You must try to check on me. Maybe I might not be here, because this environment, yeah, it's for gangsters. All right, but let's do that in maths, right? Master gangsterism in maths. And speaking of which, good people, I said to you when you sketch this, it's like you are going to cheat it in a way. How do you cheat it, right? After drawing the shape, right, all you have to do is to go to the turning points. Look at your turning points there. The turning points, it was 1 and 0, and then 3 and 4, right? Those were the turning points. So you just look at them, and then you're going to say the turning point with the lower x value, with the smaller x value, is which one? It's 1 and 0, ne? The one with the smaller x value is going to be on the left. So it means here it should be what? It should be 1 and 0. And then what about here? It means here it should be that that 3 and 4. Okay? That's how you cheat it. You start with the turning points. After getting the turning points, right? And focusing on the x values only. Don't focus on the y. No. You focus on the x values. The one that is larger than the other will be on the right. The one that is smaller will be on the left. After that, what do? You then go to the y-intercept, right? The y-intercept says 0 and 4, right? This one, it says 0 and 4. That is okay, right? Or you could start with the x-intercept. It's up to you. In fact, let's start with the x-intercept first. So let's write it here, turning point, and then we go to x-intercept, and then we go to y-intercept. Now, when you go to the x-intercept, you have 1 and 0, and then 4 and 0. Ask yourself this question: how many x-intercepts do I have? 2, right? You have 2 x-intercepts. Since there are 2, it means you must draw a line here that is cutting like this at 2 points, or it must be like this, right? Your line must be cutting between 2 points there, meaning this point and that point, or at the bottom, which will be this point and this point there. However, we don't really know where to cut, right? So you will be guided by one of them, right? You see this 1 and 0, it's the exact same as this one, right? It means we must draw our line here, right? It means we must draw our line here. Nice. What a straight line. So this means this will be our 2 x-intercepts. You're gonna have 4 and 0, and then you're going to have 1 and 0. Then from there, right, you look at the y-intercept now. The y-intercept, just focus on the x value. Focus on the x value. The x value is 0, right? Now, focusing on x values, right? This is 3, this is 4. Where is this point of 0? Is it between 3 and 4? Or is it between 3 and 1? Or is it less than 1? Are you able to see it? Right. Okay. So it's actually less than 1, right? Because it is just here. So because it's less than 1, your y-intercept will be here. If it was between 1 and 3, you just draw your y-axis here. And then if it was between 3 and 4, you draw it here. If it was greater, you draw it here. So in that case, you're going to draw it here, good people. And then you shall say, okay, this is here the y-intercept, which is 0 and 4, right? But to make it a bit realistic, good people, this 4 and that 4 there, they must match, right? So it means that our line, we should actually at least draw it. Just be vigilant all the time when you're answering these questions. let me see if I can but that ruler is problematic, so I'll just simply try to draw a straight line here. It's a bit of a problem on this one compared to my other board. Okay, so it is here, right? So this will be 0 and 4. We're just trying to make sure that they are actually on the same level because they have the same y value. Otherwise, this would be your graph. I hope that is clear, good people. So that is your f of x. You get your full marks there. Right. Then there's this question that they like to ask, right? To say, use the graph to determine which values of k for which these will have 3 unequal roots, right? Now that one is actually a bit of a chapter on its own, but there are predetermined solutions to it, right? So usually if you just see 3 roots, right, it will mean that your k, right, rather you must move this line between the 2 turning points, isn't it? You must move the line between 2 turning points. So that is why the answer to that, you will just say k should be between the minimum and the what? And the maximum. Now the minimum is what? Is 0, and then the maximum is what? The maximum is 4. Okay, so for questions like that one, for 8.3, right, usually they just come in there to, you know, increase the value of the question paper. However, that's how you would answer them. Okay, but I then wanted to rush to interpretation, right? Interpretation given the equation, right? See, how do we solve questions on interpretation given the equation? So here what we can do, right, is to understand the following principles of interpretation. When they are looking for an equation of a cubic function, okay, we'll look at a question that is asking about an equation, but you must know that the substitution of points is what is going to assist you. Substitution of points, that is what is going to assist you, good people, nothing else. Substitution of points, right? Then now they say sketched below, we have what? Sketched below we have the graphs of this and that, right? A and D are the x-intercepts of f. Very important. A and D are x-intercepts, and then B is common y-intercept for both. The fact that they said they're x-intercepts, I don't waste time. I then easily say, okay, it means here I'm going to have x, and then I'm going to have 0. Remember that x-intercepts means the y is 0. So even for D, we already know that it's 0 here. We just don't know x, right? I can call it x1, x2, but to make things easy, I'll just say I don't know the value there, so I'll just put 0 there. And then B, they said it's a y-intercept, right? It's very, very important to always label the known, label the x, y intercepts, okay? Always make sure that you label them. So it means this one, we know that we don't know the y value, but the x is 0 for B because it's a y-intercept, right? And then, do you see that squared I told you about? Let me just zoom into it. Do you see this squared that I mentioned, that when you have the squared, it means one of the x-intercepts is a turning point, and you can see it. This is also a what? A turning point, as we can see there, right? It's also a turning point. So whenever a graph has that squared here, has this squared, that will mean that the graph, one of the points is also a turning point. That is okay then. All right, and then they say 8.1, write down the y coordinate of B, right? Listen carefully. They say write down the y coordinate of B. Well, B, we only know the x coordinate. How do we get the y coordinate now, right? Well, remember, b is on two functions, right? B is on f and then it's also on g. All you have to look for is a function with information that will assist you to find the coordinate of b. So when you look at grx, right, grx is equal to mx plus 12. It's a straight line. This is a straight line. We know that here x is 0, right? So if you were to put this, write this as y and then put 0, even though you don't know the gradient, but if you were to put 0 here, what are you going to get for y? You're going to get 12, which means b is actually 0 and what? 0 and 12. So therefore for 8.1 you can simply say the y coordinate is equal to 12. Right. And then 8.2, calculate the x coordinate of a, right? Not the full coordinates, just the x coordinate of a. Now for a here, good people, we know the y value, right? But we don't know the x. So the question would be, how do we get the x coordinate, right? You ask yourself, the point A is on which graph? It's on the graph of f, it's also on the graph of g, right? However, right, it's important to use the one with most information, right? When you look at grx or g of x, it's mx plus 12, right? Now, since it's mx plus 12, we do not know the gradient. Now, to get the gradient, good people, what did I say? Substitution of points. So you already know b, right? You can substitute b there, right? Or let's see, if you substitute b there, x will be 0 and y will be 12. Okay, no, that one is not going to assist us, right? So this means, right, so this means, okay, we might need to use maybe f there, right? We might need to use f there. So let's see, our f of x is equal to x minus 2 all squared, and then we have x minus k all squared. No, x minus k only. Great stuff, right? Great stuff. Let's see. So for a, right, for a, we know that y, this is the y coordinate, right? The x coordinate. Y is 0, so we can put 0 here, and then we do not know the x coordinate, right? So we can just say this there. Right, we can say this. And then, what is the value of k? Okay, to get the value of k, we will need to know what are the coordinates of d. Ne? Let's see. Yeah, we might need to know the coordinates of d. So in that equation, let's first start by substituting b into that equation, right? Try to substitute first b into that equation there. Y is 12, right? Y is 12, and then x is what? X is 0. Remember, b is in both graphs, right? So you need to get k first before you can say I'll get coordinates of a. So try to substitute there. X is 0, right? And then you also say 0 minus k. In that case, you will have 12, and then you will have negative 2 all squared, and then you'll have minus k. Again, then you have 12, you have 4 into minus k, and then therefore you have negative 4k there. Therefore, this gives you k to be what? You divide by negative 4 both sides, you get negative 3 as k. Now that you have k as negative 3, right, you then say, therefore, I know now that my f of x is equal to x minus 2 all squared, and then x minus negative 3. Okay, then once you have this, right, you can then say, okay, our f of x is x minus 2 all squared, x plus 3. Now you have the equation of f, right? And now since you have the equation of f, good people, that means remember, this gives you, this allows you to get the x-intercepts, since A and D are x-intercepts. I want to take you back to when we calculated the x-intercepts. Do you still remember that when we calculated the x-intercepts here, we actually took the equation, we factorized it. Remember that it was also in a factorized version, right? Then we said let y be 0, right? Then we were able to get our x-intercepts, which was the value of the two x-intercepts there. So that is what we are similarly going to do here, to say we're going to let our y be 0, right? And then we shall say write this x minus 2, remember, as x minus 2 times x minus 2, and then that. Therefore, your x will be 2, or the x will be negative 3. Which means that your x-intercept is 2 and 0 and negative 3 and 0. However, A should be negative, right? And then D should be what? Positive. So this tells you here that the x coordinate of A will be what? Will be negative 3. Another thing I want you to actually realize is that the x minus 2 all squared, this part, this will be the very same point, which is a turning point and also an x-intercept. That will be the point. So it means already you know that the turning point or the x-intercept will be 2 and 0, as you can see there. That part will always give you that point, which is a turning point and an x-intercept. Let me show you even on the previous one, good people. Do you still remember we had x minus 1 all squared? It means x is equals to 1, or rather 1 is to 0 should be your x-intercept and a turning point. And you can see here 1 is to 0 is the x-intercept and also the turning point. So that's what you must always look out for there. It means already we were given the coordinates of D. How nice. Right, and then look at 8.3. It then says if k is negative 3, calculate the coordinates of C. Right, if k is negative 3, oh well, okay, we got it in the previous one, right? Yeah, it means there is actually another way of solving it. Usually if they give you something you solved before, it means you used it. Yes, it's a longer method, but you could have done it in a much simpler way, right? But I would prefer that for now. For now. And then if k is negative 3, calculate the coordinates of C. Now what is C? C is a turning point. So how do we get a turning point, good people? Remember, we find the derivative first, right? So to find the derivative, we need the equation of f, right? We know that f of x is equal to this one here, right? F of x is x minus 2 all squared and then x plus 3, right? Then from there we need to expand first to get it in a form we can actually factorize and to derive and get. So x minus 2 all squared, remember that will be x squared minus 4x and then plus 4 multiplied by x plus 3. And get, then you multiply inside x times the x squared, you get x cubed, x times the negative 4x, you get negative 4x squared, x times 4, you get what? 4x. Then 3 times the x squared, you get 3x squared. 3 times the negative 4x, you get negative 12x. And then 3 times 4, you get 12. Then from there you can say I have x cubed, negative 4 plus 3, negative 4x plus 3x squared, right? It will be negative x squared. And then 4x minus 12x, that will be negative 8x, and then you have plus 12. Now that you have this, you can find the derivative, good people. Then you have 3x squared minus 4x minus 8. Now that you have this, let's remember that at the turning point you are going to say the derivative is equal to 0. Yeah, Yes, you can ask, ma'am.
Why are you saying minus 4x instead of minus 2x?
I said 3x squared. Oh, so sorry, so sorry. Thanks for that. It's minus 2x. Thank you so much. Let me remove here. Yeah, it's minus 2x. Then you can write it as, yeah, and then minus 8. Then when you find the derivative, remember you will equate to 0. Okay, let me maybe do this. Yeah, nice. Give me some space there. So I'll equate it to 0, right? At the 10 points, the derivative is 0, 3x squared minus 2x minus 8. Then you can use your quadratic formula there, right, to get the x values. However, I think, let me see, 2. I think one of them should be 2 here. 3 times 2, and then there is 4. What can we get? 3 times 2 is 6, 6 minus 4 is 8, so negative plus, right? So therefore, our x should be negative 4 over 3, or our x should be 2. Alright, so now it will mean that the coordinates of C, right, already we know that this 2 is for what? Is for D, because D is the turning point, is a turning point also. For C, it will simply be negative 4 over 3. So now you find the corresponding y value by substituting into the original equation, right? By saying f of negative 4 over 3 is equal to negative 4 over 3 minus 2 all squared, and then negative 4 over 3 plus 3. Right, so I don't know if you can assist me with your calculator there. Minus 10 over 3. Yeah, okay, yeah, so I don't know if maybe, yes?
Oh, I calculated for the whole value, and the answer is 18,52.
Remember, you need to write it in fraction form, ne?
Okay, got it. That's the fraction.
Oh, it's how much?
500 over 27.
Oh, nice stuff. Okay, that's nice there. So that will mean the coordinates of C, right? It will mean C is negative 4 over 3, and then 500 over 27. Right. So that is 8.3, right? And then that is how you would solve it there, making sure that you get the coordinates, right? Now you have the coordinates of C. Then the last question, for which values of x will f be concave down? Yeah, they like it, concavity, you know. They like it. So what I'll do, I'll send maybe another link, and then we can try to work on that, right? And maybe finish off that.